Guys, and welcome back. Today we are going to be going on to our next topic in Calculus 1.2. Rates of change and tangents to curves is what we're going to start off with. So basically, what we're talking about here is the average rate of change of our function y, or f of x. And so what that means is it's just our delta y, so our change in y is what this little triangle means. It's named delta y over delta x. And so if we were to express that in terms of functions, it would be the f of x2 minus the f of x1 over x2 minus x1. And so we take this x2 minus x1 and we replace it with h. So f of x1 plus h minus f of x1 over h. And so if we're going to look at this graphically, we can see that we have x1 here at this point, and then we have x2 over here on the right further along. And so their curve built by this function, and our h is going to be this little orange distance here. And so what we have here, this pink line, is a secant. And so what the secant is basically just a direct line. It's just a line joining 2 points in a curve. And so this is going to build the foundation of derivatives, and that's a major subject in calculus. So just be prepared for that and the average rate of change. But now we're going to want to look at an example. And so looking at this example, we have y equals 16t squared. This is from Galileo dropping a rock off our cliff as our example. So as you can see over here, with my fabulous artwork, of course, we have our cliff, our diamond rock, and then a bird in the background, and it's falling to some water. Okay, so our goal is to find the average speed of our rock from t equals 0 to t equals 2, and that's going to be in feet per second. So if we do that, we just have to find delta y, and remember our x is replaced with t, so delta y over delta t. And so if we remember our original equation, it's going to be f of x, so f of x2 minus f of x1 over x1 minus, or over x2 minus x1. So replacing that, we have x2 is equal to 2 and x1 is equal to 0. Okay, we got that from our time equals t equals 0 and t equals 2. So 16 times 2 squared minus 16 times 0 squared over 2 minus 0 is in fact going to be 32 feet per second. So this rock has an average speed from time 2 or 0, we can say that's right now, to 2 seconds. The average downward speed is 32 feet per second. Now if we wanted to find the instantaneous speed, now this is where complex ideas like the derivative are going to get involved in future times, but we're going to find the instantaneous speed at t equals 1. So this is where the idea of h becomes very integrated or very important. The idea here is that we're going to try and make h 0 so that it will be an instantaneous rate or speed. So you can see here that our formula is delta y over delta t, and so we put in our 16t squared for our function and replaced our x2 minus x1 with h. But you see here, if we want to if we want to get h to be 0, we can't do that because you can't divide by 0. So we can do it incrementally. So if we have h is equal to 1, then this function will have a instantaneous speed of 48. If we try and make that h get closer and closer to 0, you might see a general trend here. At 0.1 it becomes 33.6. At 0.01 it becomes 32.16. Not listed here, but it is true. At 0.001 it becomes 32.016. And so if you can pick up on that general trend, you can see that as h tends towards 0, it in fact, the speed, the instantaneous speed at this moment tends towards 32. And we are going to evidence that in our next slide. So, instantaneous rates of change and tangent lines. So we have another problem here. This is the breeding of bugs. So as you can see, we have days along our x-axis here, and the number of bugs in 50 increments along our y-axis. And so what you see here is the graph of that growth of the bugs. And then we're going to get into this triangular stuff in just a moment. So our goal is to find from day 23 to day 45 what the average rate of change was, and that's going to play into instantaneous in just a moment. So basically, we have built this triangle, right? You can see here, this triangle over here. And so we are going to calculate what delta P is, so the change in population, which would be our vertical change, with our delta T, so our change in time. And starting at day 23, we do 45, way over here, x2 minus x1, which would be h, is equal to 22. And so that is on the bottom here. And then to find delta P, we just do our high population, or what at 40 days or 45 days it's equal to, minus the f of the function with 23 plugged in, which gives us 190. And we can see that on the graph. It's not too zoomed in, so it's a little bit more challenging to see. But basically, we end up with 190 over 22, as you guys can see over here. And so that averages out to about 8.6 bugs average growth during this time period. Now, if I asked you to find the instantaneous rate of change on day 23, how would you do it? Well, the instantaneous rate of change is exactly the slope at this point, but we can't find the slope, so we have to find 2 points that form exactly a line between these two, or they form a line with this along it. And so the best way to do that is, you can see that we had a secant here from from 23 days and 45 days. So if we keep moving that secant closer and closer to our curve that our point lies along, so this curve, hold on, let me make sure you get that exactly. So this curve right here, right? This one that it lies along, we want to get it to that growth curve. So the way we do that is we keep incrementally moving secants over and over and over until we find a good set of points that line up with the curve, and usually you'd prefer them to work out easily mathematically speaking. So for example, the points that I have are on day 35. We had this, you can see it's darkened a little bit. This blue line is going to be our tangent line. It just barely touches this. You know, if you had a circle, a tangent line is very easy to find, right? Ooh, that's not the circle. If you had a circle, a tangent line is simply where it touches at one point, right? That's not too challenging. But the idea here is that it has to touch at one point and have an equal slope. So we keep moving these secants along incrementally, and eventually we get to the point where we can find a tangent line. And so once we've done that, we find 2 points that we can select to find the slope of that line. It's very easy, you know, y2 minus y1 over x2 minus x1. And so here we have at day 35 there are 350 bugs. At day 14 there are 0 bugs. Oh, excuse me. We take the points where the line is. So at 14 and 0, and 35 and 350. And so when we subtract that, we get 35 minus 0, which is this point right here, and this point way up here. 35 minus 0 over 35 minus 14, which gives us an end result of 16.7 bugs on day 23 approximately. So today we covered average rates of change and instantaneous rates of change, preparing for our lecture on derivatives. Thank you for watching.